Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hamzi Aziz bin Azman. My metric number is MA20046. Today, I want to discuss estimating bare module cost non-base for pump and compressor. So, the part 1 is bare module cost for pump. The equipment type is centrifugal. The material of construction is carbon steel. The capacity is 1364 meter cubic per hour or 0.3788 meter cubic per second. So the pressure of the pump is 26 bar. The head of the pump is 223 meter. So the next is decide which equation to be used, base or non-base. For the situation given is doctor asked us to calculate for the non-base. So the formula for the non-base for the pump is CBM CP0 time B1 plus B2 FP FM. So we need to find the value of the formula. Next, first we need to find the CPO 2001. So we need to assumption heptane is used with density of 684 kg per meter cubic with 80% efficiency. So the first is P rho G QH. We need to put the value, which is 684 kg per meter cubic time 9.81 meter square per second time 0.37888 meter cubic per second time 223 meter divide by 1000. So we get the 566.933 kilowatt. So to get the WS, we need to divide by 0.8. 0.8 we get from the efficiency 80%. So we got 708.67 kilowatt. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Muhammad K03 Engineering Ka19060. So now I will continue to find the CP node for 2001. Just now we have our shaft power value, which is 708.67 kilowatt. So by using that value, we will try to find the CP node per shaft power through figure A3. So by using that value, we found that our value for CP node over shaft power is $80 per kilowatt from figure A3. So by using mathematically, we found that our value for CP node for 2001 is $56,693.29 for our value for CP node for 2001. Find the constant C1, C2, and C3 to be used into the equation for log 10 FP. So since our pump is centrifugal, we found that the value for C1, C2, and C3 is negative 0.353. So the next step is we will try to find the value for constant C1, C2, and C3. So our pump is centrifugal, so our C1, C2, and C3 is negative 0.3935 for C1, 0.3557 for C2, and the C3 is negative 0.00226 because our P is between 10 and 100 range. So the last step to find the FP, we will insert the constant into the equation. So our equation is log 10 FP equals to C1 plus C2 log 10P plus C3 log 10P squared. So we found that for our FP is 1.4517. So that's all from me. Thank you.
I am Ahmad Omar bin Muhammad. ID number is AA19275. Now I will present about how to get a material factor or FM using table A3 and A.18. First, let us look to table A3. The type of pump that we use is a centrifugal pump, and the material of the pump is carbon steel. As shown in the table A3, the identification numbers is 38. After we get the identification number, we can proceed to table A.18 that we need to draw a line on the table. As the result, the material numbers or the material factors that we get is 1.6. That's all for me. I will pass to the next presenter. Thank you.
So next we have the cost index from 2001 and to present, which is the CEPCI value for 2001 is 202.3 and for 2001 is 394.3. And then we can calculate the bare module cost for the base time by using the formula of CBM equal to CP multiplied by B1 plus B2 multiplied by FM multiplied by FP. And then gonna get a value of 56693.29 multiplied by 1.89 plus 1.35 multiplied by 1.4517 multiplied by 1.6. I'm gonna get the value for bare module cost in the base time, which is 2001, is $284,921.88. And for the bare module cost in 2021, which is the current time, we're going to use the formula that is C 2011 multiplied by I 2021 divided by I 2011. I'm going to use the value of $284,921.88 and multiply by 702.3 divided by 37397. I'm going to get a value for bare module cost in 2021, which is $504,031.83.
Assalamualaikum and good day everyone. I'm Usman Reza and I'm going to continue on this part for the calculation, which is bare module cost for compressor. So this is the description of the compressor that we're going to solve today. This compressor type is 1 HW370N and the type of compressor is rotary. Natural construction is nickel. The pressure is 6 bar and the free air delivery or FAD or volume rate of flow for this compressor is 660 liters per minute. So in order for us to solve this compressor, we have to decide which equation to be used first and decide whether this is a base case or a non-base case. As for this compressor, we'll look on the description again. The material is made of nickel and it's not carbon steel, and the pressure is 26 bar. It is much higher than the ambient pressure, so it will be considered as base case. A non-base case, it will be considered as non-base case. So for this compressor, it is also a special case. So the bare module cost equation will be CBM equal to CP0 times FBM. The CBM is representing bare module cost, and then CP0 is the purchase equipment cost, and then FBM is the bare module equipment factor. So if you can see that we have two unknowns here, which are the CP0 and the FBM. First thing first, we have to find the CP0. In order for us to find the CP0, we have to find the fluid power, WF. And the WF equation is pressure times the FAD, free air delivery, divided by 600. Pressure must be in bar, free air delivery must be in liter per minute. Then you just times it, 26 times 606 from the description that we got, and then divide by 600. The 600 is constant, it will never change. So the fluid power that we got is 26.26 kilowatt. So from this fluid power value that we got, we can use figure 8.1. From figure 8.1 that we have here, it's on the compressor. So you just use your fluid power value on 26.26 there, and then just go straight to the rotary because our compressor type is rotary, and then you will get your CP0 over WF of $565 per kilowatt. Then this 565 you can just times by the fluid power that we got, which is 6.6 kilowatt, then you will get a CP note of $14,866.9.
After we found the purchase cost of compressor CWP, we are going to use table 8.5 to find the formula for bare module cost CBM. As the equipment type that we are using is a compressors and blowers without drive, therefore to find the BMA module cost, we are going to use the purchase cost of compressors CWP times with the bare module factor FBM. Then use table 8.6 to find the identification number of nickel to be used later with table 8.19. As we are using a rotary compressor, therefore the identification number of nickel alloy is 9.
Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Akram bin Muhammad Padri, ID number AA19292, and now I want to present about how to identify and find bare module factor as known as FBM, and how to find bare module cost in 2001 and 2019 for compressor. Okay, next step, we need to find our bare module factor as known as FBM. We need to identify our identification number and in table 8.6, and our identification number is 9 by figure A.19, so our FBM nickels is 9.8. After that, we can find our CBM for 2001. Base time is equal to 145,401.92, and our CBM for 2019, which is current time, equal to 222,497.49. Alright, thank you. That's all from our group.